Let's take a look at the selection sort algorithm. So on the left here we have the algorithm or the pseudocode for the selection sort algorithm, and on the right here we have a unsorted array. We have the indexes on top for each element in this array, and having a look at the pseudocode for the algorithm, we can see we feed in the array into the function. We set the iterator I to 0, which is this location here. Then we find the smallest item with index j greater than or equal to I. So basically we search the whole array for the smallest item in this array, and then we swap I with j. So for example, 4, 2, 5 and 1. 1 is the smallest. We swap 1 with the 4. Then we increment I and we do the whole process again. So let's carry out this algorithm on this array here. So for I equals 0, the length of the values array here is 4. So 4 take 1 is 3, gives us the index numbers there. Let's find the smallest item with index j greater than or equal to I. So we have 4, 2, 5, 1. 1 is the smallest, so we're going to swap 1 with 4. So our next array sequence will be 1, 2, 5 and 4. This is for I equals 0. Now we increment I to I equals 1. So the pointer is now at this location here. Find the smallest item, j greater than or equal to I. So j has to be equal to 1 or greater than 1. So it can be 2 or 3 in this case. But we're using this array here. So is index 2 or index 3 greater than or equal to index 1? No. So that is false. We continue to the next iteration or for loop. So that's I equals 1. For I equals 2, so we're now at this location here. Find the smallest item with index j greater than or equal to I. So we look forward in the array to element with index 3, and we notice that that is smaller, so we do the swap. So 1, 2, 4 and 5, swap those two, and that was I equals 2. And we now have a sorted array using the selection sort. Finally, let's take a look at the runtime of this algorithm. We can see that the algorithm, we basically go through the for loop, but each time through the for loop we are reducing the search that we need to do of the array, of the elements in the array. So we started at index 0, we had to search the array to find the 1, then we incremented the index to 1, then we searched the array 5 and 1, incremented to 5, index 2, and we had to search the last element. So each time through the for loop we're reducing the amount of search we have to do of the array to find the smallest element. So if we write out the steps, number of inputs into the algorithm, we get something like n take 1 plus n take 2 plus everything in between plus 2 plus 1. So each time through the for loop, the number of inputs or the number of search items that the algorithm has to do within the array is reduced by 1. And this here can be simplified to n squared plus n divided by 2. And this here has a big O of n squared.